Good morning, dear analysts. Welcome to week 5, where we use SQL to determine ER wait time analysis for our client in the pharmaceutical. So let's look at the business problem. Our client's pharmacy operates a large network of retail clinics, including emergency room services. However, recent internal reports have revealed that over 20% of locations have average wait times exceeding 2 hours. Long wait times are negatively affecting patient satisfaction, staff efficiency, and the pharmacist's reputation as a provider of fast, convenient care. This is not just a number on a report. It reflects real patients, real frustration, and lost opportunities for the business. So we have to come up with a clear analysis to actually determine what locations are having those issues, and this will help the pharmacy executives come up with a solution. So why is this analysis necessary? This analysis is necessary to solve the pharmacist's needs, because to the pharmacy, they need a strategy that is backed by data or data driven. So they have to determine which locations are performing poorly, which departments are creating the bottlenecks, how widespread the issue is, and whether things are getting worse or improving over time. So our analysis will provide their executive with actionable information, the kind they can use to reallocate staff, streamline operations, and redesign the patient experience. So why are we analyzing each determinant? Let's look at the determinants. The first determinant is the location. Why it matters is because different clinics may face staff shortages, volume spikes, or process issues. Identifying location level performance will help target support. On the department, not all delays are equal in the department. Some departments may be bottlenecks. By analyzing department level data, we can improve specific services. Under the monthly trend, we can see trends over time, and this will help the pharmacy assess whether interventions are working or whether wait times worsen at peak season. Maybe like the flu season. Is it that we have or they have too many patients to cater for, or are they short-staffed for particular seasons? We are going to use metrics like percentage of locations with greater than 120 minutes wait time to give leadership a benchmark to track system-wide performance. Okay, so let's get started using Postgres to determine this. So let's begin by creating a database for this project. We'll right-click on database, click on create, and then database. So let's call this database CVR. So we'll say CVRDB. We click on save. Let us click on the query tool to begin to create our first table. To create our first table, we will start with create table. And the table name is departments, just as we have it in the file we'll be exporting. Okay, open parentheses. So now we will enter the columns of that table. Okay, so in that table we have department ID, and the department ID is an integer, so use int. We'll make it a primary key. Okay, so primary key. The primary key here is the unique identifier of that table, which is the department ID. Okay, say comma. Let's enter the other column name, which is department name. Okay, and we'll put in the data type, and this time we'll be using varchar. We're putting the limit at 100. So we'll say not null, because not null here will add the constraints. Okay, let's close this query. want to create a table here called department with the following columns: department ID and department name. So let us label this properly. So I will use comment. I'll say create department table. Okay. So let's execute this. So we have successfully executed this. So now that we have successfully executed this, we can import this table. Okay. Let us go to this database, CVRDB, expand schema, right? And right click on schema and refresh. We expand tables. Under tables, you see now that we have our departments table. Let's right click on departments table. Let's just import data. Okay, so I want to import departments, right? Click, then I go to options, make sure header is checked, it's comma delimited. Okay, let's look at the columns, department ID and department name. That is good. So we go ahead and click OK. So we have successfully copied that table. So to see the structure of the table, we will say select all from what departments, right? Our departments table. Okay, so let's see how our departments table look like. We execute this and we can see our departments table. So let's go on to create the second table. Second table is the location table. So let's just create table, locations, open parentheses. So let's input the headings of the table. So we have location ID, and location ID is an integer, and we are going to make this the primary key. Location name now, location name, and location name being a text, we'll use varchar and give it a width of 100, and we'll say not null. Okay, let's add that constraint because we don't want to import null columns of values. Okay, so let us execute this to create this table. So we have done that successfully. Let's just refresh this and we can see our locations. Let's import our data. Okay. Okay, open. Okay, this is good. And our columns are this. We'll say okay. Okay, we have successfully imported the location table. Shall we see the location table? Select all from locations. Let's execute this. And yes, this is our locations table. Okay. So the third table will be our patients table. Okay. So let us create the patients table. Create table, patients, open parentheses. We have patient ID. Patient ID is meant to be an integer. Let's make that the primary key. Then we have the following columns as well. We have the check-in time. The check-in time is timestamps. That is the data type. The timestamps data type will ensure we can store the data and time with the time zone. Okay, so we'll say not null. We also have the column checkout time using the same timestamps and not null as well. So remember that we created a department table as well as the locations table. And in these two tables, we had the location table, the location ID, in the departments table, the department ID. So let's identify a connection here from the patients table so that you remember in relationships, in creating relationships, we have the dimension tables and we have the fact table. So the patient table here now is going to serve as our fact table. So let us connect this table based on or to the locations as well as the departments. So the following query will do just that. So from the department table, we have the department's ID, right? department's ID. And that department ID was an integer and it had the constraint not null. Okay, so now we want to make the reference. We'll say reference is departments, that is the departments table now, will be referenced by the department ID. Okay, so in this table now, in the patients table, this is referencing the primary key of the departments table. Okay, so say comma. Let's do the same for locations. Okay, let's do the same for what locations. We will say locations, location ID, integer not null. Okay, so we'll say references now. So we want the locations table, right? Reference by the location ID. Okay, we'll say comma. So what is also important is that we add a check because we actually want to ensure that the checkout time is greater than or equal to the check-in time. We don't want a situation whereby check-in time will now be higher than what the checkout time, because that wouldn't make sense. So we'll say check as a checkout time column, as this column here now, the checkout time column here should be greater than or equals a check-in time. Let's close this and run this query. All right, so there is an error here because I omitted T. Okay, omitted T here, so it doesn't recognize that. So T. Okay, so let's go ahead and run that again. So that is correct now. Let us refresh and look at that table. We now have our patients table. So let's import our patients data. Okay. Let's look at the options, still as it were. So, okay. All right, so we have successfully copied that data. So let's look at our patients table. Okay. All right, so this is our patients table. We have the patient ID, the check-in time, checkout time, department ID, and the location ID, creating the connection between our patients table, the departments table, and the location table. All right. So well done. Now, let us go to solving the problems proper. So the first we'll be doing is to calculate the wait time per patient. Okay. So imagine you are a data analyst at CVS Health. Executives are complaining that 20% of ER locations have long wait times. That is, patients are waiting for over 2 hours. Now, they have asked you, how long does each patient spend in the ER and where? Okay, remember we have locations. Remember we have checkout time and check-in time. So we will be using those to determine how long patients are waiting and where are they waiting the longest. Okay, so let us do that now. Okay, so we'll say calculating wait time. We'll be using the common table expression CTE to create this. So a CTE is a temporary table that stores intermediate results. So this makes the query easier to read and reuse. You see how we'll be reusing certain aspects of these wait time calculations to calculate like the average wait time and so on and so forth. So let us begin writing our query. So we'll say wait time as, open parentheses, let's hit enter, say select. We want to select patient ID. We want to start with the ID, right? Patient ID. comma, then location ID, comma, then department ID, comma. Okay, now let us check the time difference. We want to check the time difference. So the wait time now is what we want to determine. So we'll say extract, open parenthesis, epoch. So like I said, this is calculating the time difference using the checkout time and the check-in time. Okay, from now, let us basically say checkout time minus check-in time, right? So check out time minus check in time. Okay. So when we subtract this date now to get the date difference, we want to present it in minutes, right? So we will say divide by 60, divide by 60. Then we want to present that in the column as what? Wait time, or wait minutes rather. Okay. So let's continue from what? From our patients table. Okay. Let's add this condition. We'll say where checkout time, because we don't want to be returning values that are not corresponding to our results. So we'll say where check out time is not null and check-in time is not null. So I could use lowercase to write the functions, but I just want consistency, okay? Let us add this, select all from wait times, close this. Let us add S here for consistency and correctness. Okay, so let's execute this and see. Okay, so department ID does not exist. So let's look at what the error will be. So let's see here. Okay, it's departments we use. Let's make that S and run it again. Okay, we have gotten our output. So these wait minutes that we have here, okay, is a value gotten from the subtraction of check-in time from checkout time, okay, and divided by 60. You can see decimals that we have. So we should round this up to 2 decimal places. What do you think? Okay, so let's round this up to 2 decimal places. So I'll be adding round here, open parentheses, then say comma here, make it 2 decimals and close the parentheses. Run this again or execute this and we see we now have it in 2 decimal places. Okay, so let me break this down line by line. So you can find a document explaining block by block, line by line, what each function does and why we are doing this. Okay, this wait times here defines the CTE. The CTE is named this, right? Wait times. The patient ID is the unique ID for each patient that we had as the primary key of the patient table. The location ID is the unique ID that represents each CVS branch. Okay. Then the department ID is the ID that represents each department that the patient interacted with. In this line here, we used this to get the wait minutes, that is, to subtract check-in time from checkout time. So this gives us the time interval. So, but let's break this further. The extract epoch here from converts the interval into seconds. So they divide by 60 now, convert that interval in seconds into minutes. Round now here was added, round our results to 2 decimal places. And you can remember, we talked about aliases in the last class. That is why we give it an alias called wait minutes. This column alias here. This line only returns row where both check-in time and checkout time have actual values, even though we had already dealt with this with a constraint in the beginning. For instance, if you had not dealt with it, you can use this to still ensure that we don't have a return of a column here that is null. Okay, so that is it for the checkout time. And why is it important to calculate the checkout time? In hospital scenarios, you see that emergency is actually an emergency, something you quickly have to dash in and dash out. Okay. Now, in this case, imagine you have people walking in, kind of a walk-in, the pharmacy or the clinic prides itself as handling its work in efficiently, managing time, and ensuring that patients are appropriately and adequately catered for in real time. Imagine that you have people waiting for 2 hours before they are attended to. So that is no longer appropriate. So this is why this pharmacy will want to, or this clinic will want to do this to ensure that they can tighten their strategies to make sure that patients don't wait for longer and they keep to their mission statement. Let us progress to get our average wait time by location. Okay, we will say as a comment, average wait time by location. And remember where we said we can create CTEs and CTEs can be reusable, right? So what I'm going to do now is to copy a part of this. Okay, copy a part of this wait time CTE from here. Okay, I'm going to copy this so that we can reuse it. So I'm going to paste it here, and then we continue the second block of this query to calculate the average wait time by location. Okay, so I'm saying, comma, let's continue. I'll say location, AVG, that is average underscore wait, as, open parentheses, say select, L dot location name. Remember the location name in our location column. Remember why we will use round here? Because we want to round our figures, right? So now the average, okay, the average function will say W dot, remember this wait minutes, right? Wait minutes, the 2 here is that we are rounding this into 2 decimal places as average wait time in minutes. We'll say from wait times W. Now we are going to use the join. We'll say join locations L on W dot location ID equals L dot location ID. Let's group by L dot location name. So let's write the block 3 of this query. Say select all from location, that is from the CTE we created, right? Location AVG or average weights. Then let's order by average wait time in minutes in descending order. Say order by this column, right? So I'll copy this, okay? Average wait time in minutes, and want to order in descending order. Let's close this query and execute it, and we will discuss it block by block. So before we run this, let us correct this. So I'm going to take this out because it's not supposed to close it here. End this query here. Let's close this CTE, location average weights, and we need to close it before the select here. Okay, so we have closed that, and we can go ahead and execute it now. All right, so we have executed the average wait time. So these are outputs. Our average wait time was calculated per location, right? And you can see our average wait time for each of the location of the pharmacy. So let us discuss this code or this query block by block. You see that this CTE was what we use in calculating our wait time by location, or rather, what we use in discussing our wait time. So we added this to calculate our average wait time by location. So we had already explained this, and explanation hasn't changed. So let us focus on this area, okay? Breaking this into three blocks. That is block one, we had already discussed block two. Let's look at what is happening in block two. So block two here takes the patient level data from wait times and joins it with the location table to get human readable names. That is from our location, thereby computing the average wait time per location. We use join here. Since we did not specify the type of join, say left join or right join, SQL defaults the join to inner join, which is exactly what we want. The join returns only rows where they match the location table. Okay. The third block here, the select all helps us to get all columns from the table to view, basically here. Then from location VG weights, use the data stored in this location AVG weights table. Then the order by average wait time in minutes in descending order actually helps us to order from highest to the lowest. Okay. All right. I hope that is clear. Okay. So let us head on to identifying problems location. That is a location where we have wait time greater than 120 minutes. So let's go ahead and do that. Identifying problem location with wait time greater than 120 minutes. So as usual, we are still going to be reusing that part of our wait time CTE. We are still going to be reusing that. So let's just make that block for the class sake. I'm going to pick this, paste it, and then we can continue with identifying the problem location. So here we are going to be using the join, the group by, and having functions as well. They'll be well explained. So let's go ahead. So go ahead, say select L dot location name, comma. So let us round the average wait time in minutes. So I'll say W dot, because we are using join, right? So say wait underscore minutes. And this is necessary here. The 2 here is necessary because we are rounding to two decimal place. And we want to present this as average wait time in minutes. So we'll say from wait time W. Now let us join. We want to join locations L on, that is our locations table now, L on W dot location ID equals L dot location ID. We'll group by L dot location name. Now to the crux of the matter, having an average, that is the average of the wait minutes, that is greater than 120. Let us now order by the average wait time in minutes and in descending order. Let us execute this and we discuss the blocks. So we've executed. Let us now discuss the queries. So remember this part from the first city we ever created, right? The explanation stands. Let's begin from the select here to talk about this second part. So select L.location name retrieves readable names from location. It's possible because of the relationship we created, right, with these tables. Remember, while we created primary keys in each of the tables, and in the patient table that serves as a fact table, we linked departments to the patient table via the department primary key. We did the same with the location table as well. Okay. So that is why the select here retrieves what? It retrieves the readable names of the locations, which you can see in our output here. Okay. Then the from wait times W, this one here, uses CTE to assess calculated wait time in minutes. Remember, we used these to calculate wait time, right? You can see we had used this block to calculate our wait time. And we are referencing that wait time, basically referring to it as W, okay? So that we can use it here later on, okay? Then join here, like I said earlier, it defaults to the inner join, okay? This line of query here matches each wait time to its location name, okay? It matches what? Each wait time to each location name. So now the group by, we want to group by l.location name. That is basically grouping by location name as we have it here, okay? Grouping by location name. Let's go to the having. So the having here, the having function here helps us to filter only those locations, only the locations that meet our conditions of greater than 120 minutes, okay? And as usual, the order by helps us to order in descending order. You could also decide to order in ascending order, but it is better that we start from the highest to the lowest. Now, what this tells our client is that these locations have wait times that are greater than the threshold of 120 minutes. So you can see we have 163 minutes and so on. So if it is meant for a query, they receive a query, or then we decide to, or they decide to develop strategies that will help them prevent these long and undue wait hours. Let's continue to determining the department level bottleneck. You can see here what we did is to identify the average wait time greater than 120 in the different locations, right? So let us see how departments fared, okay? Basically, I'll be using almost all of these except for the having here, okay, because we don't want this line of decision, okay? So basically, permit me to copy this and use it down here, okay? So let me just paste this here, take away this having and do some adjustments. I'm going to explain the adjustments shortly. So let us rename this to department level bottleneck analysis. Okay, department level bottleneck analysis. Okay, so as usual, we have been using the wait time CTE. So we want to create a join, basically interacting with two tables, okay? And so we'll be using inner joins here. So now, since we are looking at departments, we don't want locations right now. So we are going to be taking out the locations. Remember, we had a column in our department table or the department name, right? And we are going to use the alias D here because D basically or department name starts with D, right? So let's make this department name, okay? So these are aliases. So instead of us going ahead to write long, say the department names, we don't want conflicts. So these aliases makes our query readable, clear, and simpler. Okay, that is it. we definitely will continue with these wait minutes, because remember, we had calculated wait minutes here in our first block. Okay, we are using W as an alias for the wait times table, is CTE here. Okay, so that is what we are using the W for. So now we want to actually join departments and not location as we've started. So we'll say join department table, right? So we'll say departments on, instead of L, which we use as an alias for location, we'll say D, which is the alias for the department. We'll say on. Now, we will want to join the wait times with the department ID, right? Or using or from the department ID. So we'll say department ID, okay? And this now will be D. Remember what D means here for us, and department's ID. Okay, so we are going to be grouping by department name, and the alias we use for department is D, right? So we will replace this with department ID. Okay, so every other thing here is good to go. So let's execute this and then we discuss further. My apologies for this error. So we are grouping by department name and not department ID. Okay. So let us execute this. Now, the error we have is that w.department ID does not exist. All right. So this is as a result of the departments. Remember, if you come to our column here from the first part here, we have departments ID, right? So that is the issue here. Departments ID and departments ID. Okay. Now, I just want to point this out. Why we copied this is just for efficiency so that we don't have to write it. Join interest is between the wait times, this wait time CTE, and the departments. Okay, so we don't necessarily need the location ID. So when you are writing yours, it's not necessary to have this location ID, because without this location ID, we are going to have a successful execution. We are going to have a successful execution. Okay, so it's not needed. It's just because we're copying it. So basically, that being said, I can just take that out. Okay. What is important for us here is that we have the patient ID, we have the department ID. Okay. So from this error, it made it clear, point to us that we had it saved as departments instead of departments. All right, now we have executed this. So we corrected in the wait time table, this wait times table, we had department's ID, okay? In our department's table that we're referencing, it's department ID. So now these errors can happen. So we join departments D on W, which is our wait times, linking them as to return rows that match the department's table. Okay. Now, if we must do that, we need to match it using our the department ID from the department table. So if I add S here, it will be wrong because there is no department's ID in our department table. As you can see, we have department ID instead. Okay, I hope that is clear. All right, so what do we make of this output? We can see that this gives us the average wait time across all the departments We have written several queries to determine department level bottleneck, to identify problem locations, to determine average wait time by location, and then calculate wait time. In the attached document, we calculated two more metrics, and you're expected to calculate those metrics as well as part of your deliverables. And the metrics include monthly trend of percentage high weight locations, as well as a percentage of locations with high wait times. So in the attached document, we have already written the queries for that, calculated it, explained the steps for that. So you can study that and include that as your deliverables.